morning, guys. Welcome to another beautiful edition of Patio Productions. As you can see, it's been super sunny in my backyard, so I had to get the pop-up tent from the garage because I was getting such a sunburn out here. We can't have that. Ladies and gentlemen, today's video is just a quick review of all things that were in Chapter 15, right? So Chapter 15 was the chapter that we were working on right when we started our stay-at-home learning, and we had finished it on long-distance learning, but we never took a test on it. You were informed that we were going to finish Chapter 13 test, get that all taken care of, right? Like, put that up with a cute little bow. Right, you guys did a good job on your test. Nice. And then we're going to go back and visit Chapter 15 this week and then take a test on Friday. So that's what today's video about. Hopefully it's going to be quick, and it's just not any like first time learning. No first time learning, just reminding you about the main topics that were in Chapter 15. And so that is what we are going to do right now. And so let's go ahead and get this PowerPoint pulled up and let's do this. So yes, okay. These are our Chapter 15 main ideas. Today is April 27th. And your Chapter 15 test is going to be this Friday, May 1st, okay? So we're just going to go one section at a time and do some big broad strokes of just, certain details and stuff. So section 1 was about basically how to represent data with histograms, frequency distributions, etc. So this would be like a frequency distribution sort of table. We talked about how there can be classes, right? These groups right here are like classes where you count up things. You have to make sure that the jump between the classes is here on the left hand side. You can't have any numbers repeating, like you can't have 19,000 to 23,000 and 23,000 to 27 and 27. Like you can't repeat any of the values. And then we have like whatever the frequency of those numbers over there on the side. And then you can make this data, something like this, turn into a histogram. So a histogram is your bar graph. There's no spaces. Basically, each little one of these guys is a class, right? So again, you're noticing how like things are not overlapping. Something similar to this is the frequency polygon. Frequency polygon takes the same values from the histogram, but instead of putting like a range for like how big this bar is, they go ahead and they take the midpoint of each of the bars. So if you take this guy right here, for example, 105 to 109, the midpoint between 105 and 109 is in fact 112. Okay, so then that one data point gets a 1 for the dot, since up here on the histogram it was a 1. And then you just do that for all of the different bars. But what's interesting about the frequency polygon is, in fact, you're tying it down on the edges, right? So there is like a spot where however big the class was, you have to go backwards that amount, and from the very first one, and then an additional spot on the at your top spot. And then we talk about a stem and leaf diagram. The way that a stem and leaf diagram works is the stem is more like the tenths place or maybe even the hundreds place, and then your leaf is just all of the ones place. And it looks quite lovely just like this. Notice there's no commas. Even if there's a repeat of numbers, like there was 2 zeros right here, for like there must have been 2 50s in the list in the data set. We went ahead and made 2 different zeros. I didn't take a picture of it, but every stem and leaf needs a key, right? Where you say what one of the guys has to be. So don't forget that there has to be a key for a stem and leaf diagram. Stem and leaf plot. Just kidding. I scrambled up my words. Lots of daisies. Okay, section 2 was basically how to organize our data. We talked about percentiles, quartiles, box and whisker plots, all that good jazz. So if you're going to do a percentile, remember a percentile is basically just a fraction. It's the number at or below over the total number, and then that becomes your percentile. It always is spitting it out as a decimal. So if you got like 0.85, then that's the 85th percentile, and they would write it like P, and then they would just do like a little 85 down as here as a subscript for like the 85th percentile. We talked about how if you want to find like we talked about the important word of a median, and for a median, what that means is, okay, it's the middle term in a set of data, or like the average between the two middle terms. So to figure out your quartiles and your medians, you go ahead and you list the numbers in order, and then you just try to find like the middle number is your median. The quartile 1 is the median of the lower set, and the quartile 3 is the median of the upper set. And then those values come into play when we make a box and whisker plot, right? I do love a good box and whisker plot. So on a box and whisker plot, underneath right here would be like the x-axis, and there'll be like tick marks for all the values and whatnot. And then your median gets a big bar. Your quartile 3 gets a bar. Your quartile 1. If you take the difference between the quartile 3 and quartile 1, you'll get the interquartile range. And then you put over here the lower extreme and the upper extreme. And then just like that, box and whisker plot. So fun. Okay, section 3, we looked at averages and all the different types of averages that there were. And so there is 3 important vocabulary terms when it comes to averages, okay? Those words are mean, median, and mode. Okay, mean is basically your arithmetic mean. It's basically just the numerical average. This was the fancy notation, but guys, just add them up and divide by how many there are. The median is the middle number in your rank data, but remember, you got to put the numbers in order. And then the mode is the most occurring value. Sometimes, guys, there is no mode. Sometimes there could be more than one, or, just that's what the mode is. So easy, right? Like, I'll finish with this lesson. That was a very easy lesson that we learned that day. One more thing, guys. There's different like uses for each of these. So mode might be important for something, mean might be important for something, median. So all of them have like their own sort of like benefits. And so just, be flexible with your thinking about those averages. Okay, then we talked about, yay, this is how the data looks. This is like how you can average the data, but how much does the data vary, right? Like, do I have a list of 10 numbers and they're practically all the same right around the average, or are the numbers super spread out? So we talked about measures of variability. Okay, your range, and we've talked about this word before, but it's the difference between the smallest value and the largest value. That's your range. And then we introduced this thing called standard deviation, right? Standard deviation was like a process that we had to do. You ended up probably listing all of the X values in order. And I like to put it in a table, just because, a table is always nice to have just, like some organization to it, but you could do it however you want to. So I listed my X values. I have to find the mean, right? X bar, that's what that stands for. The average, the mean. I do X minus the mean. I subtract it. Then whatever the number is right here in this column right here, I go ahead and square that. Okay. Then what I do is I add up all the guys in this guy and we sum them up and we get a total. I divide by the number of X values that they are. This guy right here, this number is called the variance. Okay. So the variance is right after you, divide by the number of values. And then to get the standard deviation, right? So to get the standard deviation, you're going to take the square root of the variance, and that is your standard deviation, right? So great. I love it. I love it. Definitely know how to do that process, you guys. Okay, so that is a very, very important process. Okay. Another thing, and probably this was, I'm going to be honest with you, I think this was the hardest section of this unit. You had to talk about empirical rule, which was actually pretty easy, but then there was this idea about z-tables. So for empirical rule, what happened is that within, like, they kind of like rounded the values and said that within one standard deviation, so one standard deviation on either side of the mean, okay, excuse me, not the mean. I lied to you. Sorry. Around the middle. It is the mean. I'm just kidding. It is the mean. Mrs. Fox seriously is having trouble with her words today. One standard deviation on either side of the mean would be 34 and 34, so a total of 68%. Within two standard deviations, okay, if we're doing some rounded values, it's 95%, which means that next column is 13.5 on each side. And then if we did three standard deviations on either side, woof, okay, it's 99.7% of the data. Okay, but then we also learned, and this was probably the most important part, about doing a normal distribution table. I will make sure that we put out a nice paper for that for your test and stuff, but right now it should be on the back of your notes packet. Maybe what I should do is I should attach it to the assignment. So note to self, I'm going to attach that for you guys, okay? So what happened is either they could give you a z-score or you could calculate a z-score. The formula for a z-score is this guy right here. So your z-score is X minus mu over sigma. What that actually means is your X value, so your value minus the mean over your standard deviation. I know it's simple, but cute. I think so. Then whatever you got for this number, you went ahead and you found a number that correlated to it in your normal distribution table. You have to remember that the table is showing the area to the left of your score. So what that means is when we were doing these questions, we went ahead and like drew ourselves like two pictures, and you were like, okay, this is the middle, and my number is, well, whatever it is, like 1.6, and then it's giving me this, all this area right here. Okay. That's what the table is going to give you. Your value for what you want may or may not be that. It may be a piece of it. It may be the flip of it. It may be the opposite of it, where you have to go 1 minus the answer. There was lots of choices. And so probably this is where you're going to need to put in a little work this week, is to figure out, just to like really get up those strength with these guys and get it like super powerful. You might want to look at these guys. And then the last section was about curve fitting. Okay, so curve fitting, we talked about scatter plots and regressions and that correlation coefficient. So when you do a scatter plot to see like how the data is related, something that's going up, like going as you go to the right, it's going up. This has sort of like a positive correlation. If you're going down as you go to the right, it's a negative correlation. And then this is, I guess this third one here is kind of positive. It's just kind of wide. Excuse me. If you remember, what you're going for is something that is as close, like you want it to be as skinny as possible. And the skinnier it is, the closer it is to the number 1. So this guy right here, it's not that skinny, but it definitely is going in this direction. So I might give this guy a correlation coefficient of maybe like a 0.7 or something. On this one, this would be a negative value, but a little bit wider, maybe like a negative 0.5 or something. And then this one just kind of like a hot mess. It's almost like just pretty much random. So this might have a really low number, like a 0.2 or something like that. Okay. And then we talked about how to enter data into our graphing calculator, make a scatter plot, see if it looks like a line. And then we talked about running linear regressions. And so that was a lovely thing that we could do. And then once we have a linear regression, which is basically like a line of best fit, I know, pretty fancy that your calculator can do that for you. Then you can actually like solve for other things, knowing that you have this sort of like line of best fit. Folks, your homework assignment, it's going to be lasting for 2 days. There is a review worksheet, but it's kind of like a big worksheet. There's lots of vocabulary on there. And so we're just going to give you 2 days to do this. It is not imperative to get it done in 1 day. So yay. Oh, yes. Thanks, guys. You're welcome. My pleasure. And so you're just going to do this guy over the 2 days. I did provide the answer key for you guys, but use it responsibly. Don't copy. That'll get you nowhere. So I think that's it. So the homework for Monday and Tuesday is to get that review worksheet done. It is it's due when it's due, whenever it says. And just that will be worth 2 homework assignments. So if you don't do it, you're now missing out on 20 points. So let's make sure that you do it, guys. And I mean, why wouldn't you? Because hello, you are trying to study for your test, right? Okay, guys. So we are, right? We're taking our test on Friday. Okay. We're taking our test on Friday on this material. I'm super stoked for you guys. I think this is going to be another opportunity to really log in another great test score, which I'm super excited about. So yeah, I think that's what we're going to do. Okay, peeps. So stay the course. I will see you in class. It'll be so exciting. I've got some fun things planned. Fun thing planned, not things, just one thing. And I think that's it. Okay, guys, let's get our fanfare music to get us out of here and have a good day. Bye.